Good morning, afternoon or evening, depending on which time zone you're in. My name is Brian Calder. I am a research professor at the Centre for Coastal and Ocean Mapping and at the NOAA UNH Joint Hydrographic Centre. I'm also the Associate Director of the Centre for Coastal and Ocean Mapping at the University of New Hampshire, our building here. My background is electrical engineering, and I still do a little bit of electrical engineering, for example, building equipment like this, which is used to do very low cost data capture for volunteers who are collecting bathymetry to assist with mapping the world ocean by 2030. We also do the associated software interfacing all the way in the cloud and submitting our data to the various international databases. But my primary work is in bathymetric data processing, statistical signal processing, but primarily with respect to bathymetry, like this data here, which is from the year 2000 in Snow Passage, Alaska, from our friends at NOAA. My primary work is in building software which takes the raw data from this type of data collection and makes it into something useful that can be used for generating charts for hydrographic purposes and generally for ocean mapping. Our first generation software product from that is widely available in every data processing package that's used for ocean mapping. Our second generation of this software was made available starting in about 2012 and now again is generally available. And we're currently working on a third generation of that software using machine learning methods like this hidden Markov model technique to process very much higher resolution data sets, particularly with respect to LiDAR data, particularly topographic LiDAR data, where we get LiDAR measurements, laser measurements from a plane or a helicopter on the land and all the way down into the sea as well. They have issues with noise and therefore much more robust techniques are generally useful for that. I also work in systems where we're looking at volunteer collection of data, in particular systems that can calibrate themselves so that we can trust the hardware that we're using to get better data collection. This particular system here, we're looking at the calibration results, demonstrating that the estimates we had of the calibration constants are within what we measure from a laser scan of the ship, but does it autonomously. We also do systems where we do measurements of the ship from the air. This is work we did with a graduate student. We used a commercially available, very low-cost drone to do offset measurements on ships of opportunity, and we can demonstrate that with a $2,000 drone we can do it at sub-centimeter level accuracy, which is pretty nice. And we also do a lot of work in looking at how to process data that's being used, being collected by general collection systems, volunteers essentially, the general public, where what we're concerned about is the quality of the data and what use we can make of it. And so we look at things like reputation measures, as being shown here, which actually uses some work based on chess rankings, repurposed for this particular purpose. There are many more things to talk about, but I think that's probably a good introduction. I look forward to talking to you sometime shortly.